So I have to solve and graph an absolute value inequality. This one says less than, so what word are you thinking of? Stay together. My interest in someone else is small or less than. The key word is and, right? Okay. Is the absolute value sign isolated? Yes, it is. There's nothing in front and there's nothing behind. Yes? Okay. Now I can split them. Need one that is going to be positive and one that is negative. I have x minus 4 less than 8 and x minus 4 less than 8. Class, do I need the plus sign or the parentheses? No. Now what?
Add 4.
X is less than 12. If you get intimidated with the inequality sign, just treat it like an equal sign till the very end. Okay, we got one clue. What do you want to do over here? Someone said distribute. I don't want to distribute. You can, it's not wrong. I'll tell you why I don't distribute, because you can make a mistake on the signs on the inside. I'll divide by -1. If you distribute, that's fine, we'll get the same answer. So those will cancel, you're left with x minus 4. Huh? Greater than -8. If divided by a negative number, you should be flipping the inequality sign. Add 4. X is greater than -4. Okay. It didn't tell us solve and graph in interval notation, so I can keep it in inequalities. Okay, what's the keyword, class? Let's put it together. Ready? X in the middle. Smaller number on the left. What's the smaller number?
-4.
What inequality sign are you going to put there?
Less than this.
Less than. Do you see how it's pointing towards the -4? Pointing towards the -4. Bigger number on the right. What inequality?
Less than.
Less than. Raise your hand if you got x, -4 is less than x, less than 12. Good. Okay. This is new to us. Okay. Now, although you guys can get a two-dimensional graph, let's do that. I'm going to put a little message here, not drawn to scale. I just want to plot some numbers so you can kind of see it. Normally we would have done something like this, right? The graph, open circle, goes towards the right, -4, yes? And then I would have done 12, open circle, goes towards the left. It's the keyword and, so it's going to be a bar, yes? And I can test it. But I want to take it now one step further. We have an absolute value. Do you see that? So we can actually graph it now. So let's take out our graphing calculators. I'm going to teach you guys how to graph an absolute value equation, and then we can apply that. So on my calculator, you can go ahead and turn it on, and then you're going to go to y equals and press clear. Later on, if you need to, you can just write down the commands, or if it's better for you to write it down and you practice later, that's fine. Everyone say math. Everyone say complex. Everyone say that.
Complex.
So we're going to go to number 5. And there I have the absolute value. Then we're going to write in the argument, x minus 4, close parentheses. And now I'm going to go to zoom and press 6 for standard. And I have this graph. Let me go back to my y equals. Okay, so in our graph, the lowest point is called the minimum. Everyone say minimum?
Minimum.
You're like, I'm not sure what that looks like, right? We already talked about how you can click trace and kind of guess what it is. Let's see if it gives it to me. I want to get closest to y equals 0. And you'll notice the numbers keep going back up. So I know it's somewhere around 4, but I can also find that number very specifically. Everyone say second trace. Second trace. And I can actually do the minimum. Now again, it says left bound, so you're going to go a little bit to the left, to the left, to the left, to the right, to the right. Now you're going to a little bit to the right. I'm clicking right. If you want to, you can even exaggerate, like really far to the right. And then your guess is exactly. Ta-da, ta-da. Amazing. It tells me that the x-intercept is 4, and then this number is scientific notation. Something with a big negative number essentially means it's like super, super, super close to 0. So let's go ahead and make a quick sketch of that. So we said around 4, 0. Very, very close. For now, I already know kind of like my slope is going to be 1. That's not important to you right now, or how to do it. But our graph kind of looks like that, doesn't it? I'll just put a 4 here. Okay, let's put those numbers. I didn't do a good job of it before, but let's put those numbers from before. -4, and let's put 12 on here. 4, 8, 12. Okay, so what we did previously is we said this. X is greater than -4. Open circle to the right, to the right, to the right. Yes? And then I said x is less than 12. Open circle to the left, to the left. And that's what our solution looked like. Yes? Okay, let's build upon this. And let's double check. I want to use my testing points. Everyone say testing points? I'm going to test. I guess I didn't really expand my graph long enough, but I want to pick something in between these 2 points. Class, what number do you think I'm going to test?
0.
What number should you always test if you can? 0. You can even put it back into the equation. Class, 0 minus 4. Absolute value of -4 is 4 smaller than 8. Okay, this whole region in between these 2 points is true. Okay, all of this is true. Let's test -5. -5 minus 4. And what's the absolute value of -9? 9 is 9 smaller than 8. False. Let's test a number bigger than 12. Let's choose 13. 13 minus 4.
9.
Absolute value of 9 is 9 smaller than 8. False. Okay, so that I know that my solutions are between -4 and 12. Okay, so if I wanted to use interval notation, I could. It's kind of weird, but I'm going to do it from really way over here to kind of show you. -4, 12. Okay, look at the visual now. I didn't really make my graph big enough. Let's really exaggerate it now. My solutions are inside here. So if my graph, watch, this is new, okay? My solutions are up to that point now, in purple. And I'm going to go up to -4. There's like that boundary. You guys see that? So normally we've done the red. You guys are used to that. We've done the purple of interval notation, but now we're actually graphing it, and we can actually see where the solutions are. The solutions are anywhere inside this interval. Okay? So let's review what we did. We solved it algebraically. And then I graphed it. This is a one-dimensional x-axis graph. This is two dimensions because x on the y-axis. You can use your calculator for now to give you the basic shape. We can even find the vertex, which we used on the trace part. And then we can actually see where our solutions are. They're between -4 and 12, but we don't include those values.